thanks for joining this session. My name is Yehan, and I'm currently a PhD student in Wageningen University in Netherlands. And today my topic is about small green spaces, size and distribution for better cooling effects in European cities. So I'll first show this, some photos of parks. You can see here the green spaces, they can provide cooling not only as they provide cool island in the cities, but also they can express the cooling to the neighborhood or even as far as 1,000 meters. So they are as regarded as effective cooling solutions. However, if we consider about the high dense areas in the cities, for example, you can see on the in the upper image, this is the Oxford Circus in London, which is very high dense, and you hardly see any cooling elements there. And also, the below image is in a master city plan by Foster Apartments, which is high dense. And when we consider about adding new green spaces in this kind of dense areas, the large green spaces is quite challenging. That's why now the small green spaces are now getting more attention because of it has more accessible to the residents and also improve not only the social but also the bio benefits. Here the definition is for the areas that is below 1 hectare, and however, when we're considering about the cooling by those small green spaces, it's still in doubt if it's really cooling, especially at a neighborhood scale. Now there are several studies done regarding the small green spaces in cooling effects. However, there are some controversies. For example, the studies show that they're very prone to the surrounding morphologies, and that can lead some warming effects regarding the having small green spaces. And also, there's some controversy about the size. If it's below 1 hectare is cooling, or there are some studies shows under 2 hectares is very limited effects. Also, the shape of the green spaces and also the spatial arrangement, there are also some controversies, which comes with the question about how we can design the small green spaces for better cooling effects when we considering the size, shape, distribution, and the neighborhood surrounding morphology. And especially because when we consider from our urban design planner point of view, it's a process which we pre-process the knowledge and by making a design guideline, and the result can be applicable to more situations, which means that we filter some scenarios and to make it more generalized to more circumstances that the designers can use. So in this research, it was divided in this workflow, which from typologies, which is more generic and understandable by the designers, and then we, based on those typologies, make some working scenarios and then do the simulation, and then we propose the guidelines. So my focused climate is the temperate climate in the Western Europe. As you can see, the light green areas is my focused climate, and especially I chose Amsterdam, London, and Paris as an example. And then I want to find what are the most problematic areas. So what I did then is to relate the relative temperature with the local climate zone, and finding the compact neighborhood areas is most problematic, especially during the night. So that is to what are the neighborhood topologies will look like. So based on for this part, what I did is to to consider different spatial design parameters, including, for example, the height-width ratio of streets, the orientations, street density, the floor area ratio, and shape factor of the blocks, and green space area and tree covering ratio. And based on that, we can do the cluster analysis about finding combinations of those spatial parameters. And now it can be generalized into four main typologies to represent the combination of the morphological parameters. So here are how they look like, and here are some examples in the cities, which mainly is the combination of the straightways and also the orientations, which you can find more details in this published paper. So now we have the typology, which is quite generic, and the designers can use for as a basis. And then is what are the green space design, and what we did then is based on one typology, we would propose different distribution of the green space regarding the size, the distribution, and also the shape, and then multiply with different methodologies. Here is the example of how it looks like with the combination of scenario one and typology one. And then is a more generalized weather data. We extracted those heat wave days that are above 30 degrees Celsius for the three cities, and then what are the main, including air temperature, wind, and cloud. And then it is focusing on especially the inside of the green space and outside of the green space, especially the outside means delta, the difference between the green scenarios and non-green scenarios. And here are some scenarios showing the differences regarding each cases. So here, this part is still ongoing, and there are some preliminary results here. The first one is regarding the cooling inside the green spaces. You can see, especially for the typology 1, 2, 3, it has very similar trend, which placing the 1 hectare green spaces across the main street is most cooling inside, followed by next to the main street and a linear street. And this shows for the same size of the green spaces, this distribution does matter. And also for the same scenarios, regarding different typologies, the differences can also reach, for example, 3 degrees Celsius in BT. Regarding the outside, you can see actually the y-axis is the delta between the green space and outside and no green space. And it was found that you can see it's all below 0, which means that it's all cooling compared to the shade provided by the buildings. So green spaces are cooling in the neighborhood, and especially there is a trend of different typologies, and you can find that the neighborhood has wide streets with radial orientations are mostly cooling regarding the green spaces, the outside the green space. So the previous one is talking about the outside, the cooling intensity, and also regarding the outside cooling areas, it was also found that the bigger is not always the better. Like here, it shows one point is there's like a turning point at around 2 degrees Celsius, meaning that the most areas outside the green space, which 20% of it, are within 2 degree cooler, and at the same time, you can see the light blue one is almost always above, so it actually has a cooling area outside a larger cooling area outside the green space. So here are the conclusions. So we proposed a methodology framework, which from proposing generic topology, and then proposed different design scenarios, and based on that, do the simulation and find the guidelines which can be more applicable and understandable by the designers, and especially this is a process which is from real cases, real world neighborhoods, and then gradually how it can be generalized into more applicable guidelines. So thank you very much.
Thank you. And I have a question for time for one question.